Hello, hello. My voice is audible?
Yes, ma'am. Your voice is audible.
Okay, sir. Okay.
Fine.
Hello.
Yes, ma'am.
My screen is visible?
Now it is not visible, ma'am.
Okay, just a minute.
Now it is visible, ma'am.
Okay.
हाँ હું કરેલો
Ma'am, shall we start, ma'am?
Sure.
Thank you, ma'am. So good morning, all of you. This is Dr. K. Kiran Kumar, Vice Principal and Head of the Department of Computer Science and Engineering. On behalf of Chalapati Institute of Engineering and Technology, Department of Computer Science, I welcome all the participants to this webinar on face recognition using local and global feature in image processing. Coming to the college, CIET was established in the year 2007 under the leadership of Sri Y.V. Anjal Garu, former MLA in AP Legislative Assembly. The college was located in the capital region of AP, Amravati, in the Guntur city. Ours is an autonomous college under Acharya Nagarjuna University, accredited by NBA, NAC with A grade and UGC 2F. We offer both UG and PG courses in the college. Thank you once again. I thank all the participants who have registered for this webinar, and I also thank Dr. Kamini Solanki Garu for coming as resource person for this webinar. So now let me introduce Dr. Kamini Solanki. She is having 10 plus years of academic and 8.5 years research experience. Currently she is working in Parul University for 5 years with most recent experience being as an associate professor. She completed her PhD in Computer Science and Engineering from RK University, Rajkot, Gujarat, MSc from Saurashtra University, and BSc also from Saurashtra University. Coming to her experience, she is working as an associate professor in Parul Institute of Computer Applications, Parul University. And previously, she worked at ISTAR, SP University, VP and RTTP Science College, SP University, etc. She has more than 28 publications and presented papers in 40 conferences. She is a editor for 3 journals and she has published 3 books or book chapters. She has 3 funding projects completed and there are 4 patents on her name. Thank you so much, madam, for coming as a resource person for this webinar. Over to you, madam.
Thank you for such a nice introduction. So let us start our session. Today's session is based on the face recognition. Right? So everybody knows that now.
Madam, your voice is breaking, madam.
Just hello.
Hello.
Now it's clear.
No, madam, there is a break in your voice, madam.
Hello. Now it's clear.
Madam, there is a lot of disturbance, madam, actually.
Just a minute. Hello. Now, now it is clear.
Now it is clear, madam.
Okay. Just a minute.
Maybe some background noise is there, madam. That's why there is a disturbance, I think.
Just a minute. I just stopped my screen. Now it's clear, sir?
Yes, madam, it is clear now.
Okay, okay. So let us start our session, right? Today's session. So everybody know that, right? Everybody know that nowadays face recognition is the most important part in COVID situations, right? So everybody is recognized by the faces. Different biometrics systems are there, like eye recognition, then thumbprint recognition. So everything is there. But face is non-contact, right? So my main today's agenda is face recognition using the local and global feature using image processing. So now in today's situations, we all know that face is very much important. Right? So now we can do the face recognition using so many methods are there for the face recognition. But among them, today's we have used local and global. For local LVP and for global PCA, principal component analysis algorithm. Right? So face recognition is most considerable, most suitable technique for the real time applications. Right? So whenever you want to use real-time application, you can use face recognition. Right? So for that, various algorithms are there for the security purpose, authentication purpose, right? But they have so many pitfalls also, loopholes also. So there is some drawback and there is some advantages of the face recognition. Right? So in our proposed method, we have recognized the face with the combinations of two techniques, right? So it is a hybrid of two techniques. First, local binary pattern, and second is principal component algorithm, right? Okay. So main purpose of recognition is to ensure that the services or access which is used by the person, that person is authorized person, right? That must be authorized person. So face detection, there are some steps. So first step is detect the face among the multiple objects. Second is extract the features from that face, and next is recognize that face. So for the facial features, we have local features as well as the global features. So for local, we have two methods: LBP, local binary patterns, and Gabor method. For the global features, we have LDA, linear discriminant analysis, and principal component analysis. Right? So how to get the rate of the recognition? So there is 100 multiplied by NT. NT means what? The number of total images. And NS means successful matched images. So we can get the recognition rate from the images. Same way false match rate we can get. Now false match rate means what? Sometimes you are authorized person, right? But it match with the false person, right? So match is there, but it will match with the wrong person. So that is false recognition rate. So false match rate. And RR means recognition rate. So we can find the recognition rate as well as the false match rate. Right? Then we can store our images into the database also. So biometric template security using the cryptography and key generation. You can generate the key from the face also, right? So what happened in generally, it detect the object as a face, right? So it detect the face, then identify the features from that face, and then next is from that features you can compare that features with the database images, right? And you can generate the key also from for the security purpose. So there are so many methods are there as per the literature review. We have so many methods. So first method, let us discuss about the knowledge-based method. Right. So for the face recognition, we have knowledge-based method. That is the rule-based method. Right. Now rule-based method means what? There are some set of rules. Right. Knowledge of the human faces. Right. So based on that rule, you can identify that person. Right? So knowledge-based method is a rule-based method that encodes the knowledge of the human faces. Right? Okay, first there is a forehead, then eyes, eyebrows, then eyes, then nose, then chin. then lips, whatever, right? So it tries to detain the knowledge of the face and interpret the face into the set of rules. So it converts that face into the set of rules. So advantage is that it is very easy to implement, but the disadvantage is it is very easy to guess, right? It's so easy because there is a general rule. Right? Okay, each and every person have a same set of rules, right? So it is very easy to guess, right? So and if you go in a depth, right, in a set of rules, then it may generate false match, right? So the rules are too generalized, right? So we cannot use this algorithm for the security purpose. Next is feature invariant, right? Feature invariant means this method is used to find the features, right, of a face, even with the different angles and positions. So it will, take the features of the cheekbones, chin, lips, forehead, ears, nose, etc. Right? Then it is find the features of the face with the different angles and positions, like a 45 angles, 90 angles, right? So it will take the features from the different angles. But the drawback is that in feature invariant, okay, there is a if you have a different expressions on your face, right? At that time you are smiling, you are in not bad mood, then at that time it's your facial expressions, that is the drawback of this feature, right? And so in this generally feature invariant, that we can use the PCL, right? PCL. So if you have a different angle, then it will work. But if you have a different position, right? At that time, sorry, different expressions. At that time, this algorithm cannot work well. Now next, in feature environment, there is a local binary pattern is there. One of the algorithm of under the feature invariant. Now what is local binary pattern? You can see that there is a twins, but one of the twins may have some local feature that is different from other twins. Right? So feature invariant method means what? A local binary LBP operator is there. LBP operator. Now LBP means local binary pattern, right? So it will work on the texture of the grayscale. So you will convert the color image. Now color image means what? Your RGB image, right? So each image means what? That is in the form of matrix. Your image is in the form of matrix, right? So row and column is that. Right? Now each cell have some value, RGB value. So you will convert that RGB value into the grayscale. Grayscale, right? So what is grayscale image? Grayscale image means what? So R plus G plus B. So total of that RGB value divided by 3 means grayscale is the average of your RGB value, right? Otherwise, what happen? You have to do the operations on 888. Each color image have a 8 bit, right? So R have 8 bit, G 8 bit, and B have 8 bit. Right? So you have to do the process on 24 bits. But instead of that, if you calculate the average of that RGB image, right, that is grayscale image, then it is very easy to do the process on 8 bit. So that's why generally when we do the image processing, we are converting that image into the grayscale. Right? So after the grayscale, you can calculate the local binary pattern. Right? So that is very important, local binary. In that what happens, each value of the pixel is converted RGB into the grayscale. Now grayscale image have some values, right? So you can do the operations on 3 by 3 matrix, 5 by 5 matrix, that is up to you. Right? Now here I have taken an example of 3 by 3 matrix. Suppose your matrix of grayscale image have the value, for example, 3, 2, 4, then 5, 4, 5, 0, 3, 1. Right? Now you have to deduct that neighbor value from the center value. Neighbor value from the center value. So 3 minus 4, right? So if it is positive, then 1. If it is negative, then 0. Right? So 3 minus 4, right? Then 2 minus 4, 4 minus 4, 5 minus 4. So you can get either 0, either 1. Means you are converting your decimal values of grayscale image into the binary value, right? So that is converted into the binary value. So you will get the binary value of your neighbors, right? So here you can see it. So whenever we convert the deduct and converted your value, cell value into the numeric value, binary value, then you can see 0, 0, 1, 1, 0, 0, 0, 1, right? So now you have to convert that binary value into the decimal value, right? So binary to decimal conversion. So now the output is 98. Means what? The area of that particular area, right? So this particular area have the value of 98. Right? So whenever you fetch the image from the database, the same area, you right, same pixels, right, same 2 by 3 matrix or 3 by 3 matrix, you will do the same process, same algorithm on the database image, and you have to check that whether the value is near to 98, 98 or nearby 98. If it is matched, then your local features will be matched, right? Suppose in on my tree I have one dot on my tree, then the same area, same position on the database image, right? If you calculate the values of that dot, if it is near to 98, so it will fetch that image from the database, right? So local, so if you both are twins, then if one twins have a local features, some different local features to another compared to another, then even though it on twins, this algorithm can work, right? Now what is the drawback of this algorithm? The drawback of this algorithm is it will very well work on the 3 by 3 matrix, right? Means neighbors. But if you have more than, if you expand your neighbors, right, a 4 by 4 matrix, 7 by 7 matrix, or if you increase the matrix, then it will, false match rate is there. Means it reduce the recognition rate, right? So that is the drawback. You have very good results on the minimum matrix, 3 by 3 neighbors or minimum number of row and column. Right? So this will particular work on the local features. Right? So if whenever you expand your matrix, it decrease the result recognition rate. Now next is template matching. Template matching means what? It template means some format. Right? So it this method are different method. It compares the input image with the previous stored pattern. Right? So template means some pattern. So you are following that pattern. Right? So we have given one template. We have to follow that pattern, and we gives the inputs according to that template. Right? So in this method, different features can be defined separately. For example, face can be divided into the different parts of face, like the eyes, nose, mouth, etc. Right? It is very easy to implement, but the drawback is that it can be represented as a shape, right? And it can be frontal. So if you have a 45 angle, 95 angle of the faces, it this template matching cannot work well, right? So some templates use the relations between the face area of brightness and darkness. So if your face is in lighting conditions, so at that time it generates the illumination problems. Now next method is appearance based method. Right? This method are divided from statistical analysis and machine learning algorithms. So generally, this This method is used for the machine learning, right? So it has significant features of the faces of image data, like eigen face, right? Based on eigen face and eigen value. Now this is what? So this means PC algorithm, principal component algorithm. This is used for the dimension reduction. Now what is dimension reduction? Suppose, for example, we have 1,000 students, right? And we need to verify the marks of 1,000 students. So there is two options. Either I can verify one by one the marks of each and every students of 1,000. Right? Second way is I can randomly verify the marks of absent students who are absent in the exam. And second, I can verify the marks of scholar students who are scholars or topmost students. Right? So, and randomly I can verify the students who have a medium average, they are average students, who are average students. So, I in time saving, I can reduce my time for the verification. For that, I need to select the best features, right, which can be compared with the database images. Right? So dimension reduction. So we are, extracting the best feature from the face, and we are matching that features with the database images. Right? So this algorithm is used for the dimension reduction. Right? So there are some steps for that dimension reduction. So we have to find the mean of the algorithm, right? Then we have to calculate the covariance of the matrix. Then we can find the lambda value, eigenvector, right? From that lambda value is called as eigenvalue, right? Then we can find the features. After the lambda value, we can identify the sum of the features, best features from the face, right? And that features can be matched with the database images, right? This algorithm, the characteristics of this algorithm is it is very fast, right? It is very robust. It is work well with the high dimension, right? But again, the problem is illumination problem, means lighting conditional problem, and pose problem, right? Two problems are there. Next is appearance based method. That is what LD algorithm is used for the appearance based method, right? LDA means linear discriminant analysis, right? So this algorithm have a linear sequence, and you can classify the features, right? And you can match that pattern classification with the database classification. This is generally used for the machine learning purpose, but used in machine learning. So in some cases, it is faster than eigenvector, low error rate, and well, it is work well when you have a different illumination conditions, means lighting conditions, right? But the drawback is that it is only work on the small database. So if you have a huge database, LDA cannot work well, right? So recognition rate will be decreased when you use LDA on a huge database. So next, according to the some of the researchers, they are saying that a PC algorithm is the best, right, to uh, implement your face recognition method. Okay, now why we have selected PC and algorithm combinations, right? So in PC algorithm, there is main advantage is there is a high recognition rate because it will fetch the best features, right? Best features and maximum features from the face data, right? And it can work on a global feature, right? Means the shape of the face, right? Disadvantage is it will cannot work on variable work on the elimination problem and post problem, right? Now let us discuss about the local. This is about the global. PCI means global principal component analysis. It is work on the global features, the shape of your face, and extract the best features, best factors you can say. right? Best vectors from your test data. Now LBP. LBP means it is fastest execution, right? Most suitable for the real-time applications. It can remove the elimination problem. Means whatever problem by the pixel algorithm that can be solved by the LBP algorithm, right? Now PCA can work on large data, LBP can work on small data, right? So most one have disadvantage, other algorithm have that advantage. If you hybrid this LBP and PCA, you will get the good result from the data, right? Now the LBP cannot work on
Ma'am, hello, ma'am. Again, your voice is breaking, ma'am.
my voice is not audible proper.
Actually, it's breaking, ma'am.
Internet connection issues. Hello. Now it is audible.
Ma'am, now also it's breaking, ma'am.
Hello. Now it is audible. Hello.
Hello, ma'am.
Still not audible.
Now it's audible, ma'am.
It's audible.
Ma'am, again it's breaking, ma'am.
Okay. Okay. That is the reason. So you can hybrid that algorithms and you get the good result, right? For face recognition. So here we have done one experiment on this data set. So we have used a math for this, and uh, we have training set. Right? This is our training set. In training set, we have 14 images are there. These images we have trained on model and we have given 14 images. But these are the different images for the input.
Ma'am, again your voice is breaking, ma'am.
Okay. Hello. Now it is audible.
Hello, ma'am.
It is audible.
Somewhat it's breaking, ma'am.
Now it's not audible, sir.
Yes, ma'am. Now it's audible.
Okay. The screen is visible, sir.
Screen is visible, ma'am. Again, there is an issue with your audio, ma'am. Voice is actually breaking, ma'am. Sometimes it's coming and sometimes it's not coming actually.
Just a minute, I just changed my headphone.
Okay, ma'am. Okay.
Now my voice is audible, sir.
Yes, ma'am. Your voice is audible.
Okay, sir. Thank you. Okay, screen is visible, sir.
Yes, ma'am. Screen is visible.
So here we have used 14 images. That images are input images. So we have given these different 14 images with the different lighting condition as 5 images, right? And this is the database image. So we have given only 5 images in the database. So in database you have 5 images, and for the input we have 14 images, right? So these images, some of the images are not exist in the database, like a 45 angles. So in database, we don't have a 45 angles. So first one is 14 images for the input, and second is user database, right? So that 5 images we have stored in our database for the verification, right? Now this is the hybrid algorithm. So first you take your color image. Second is we have to convert that color image into the grayscale, because we know that a LVP work on the grayscale image, right? Then we can find the mean of the image. Find image means what? It's a matrix data in the form of matrix, right? So we can find the mean of each column, right? Then subtract that mean from each row, right? So, and then we have calculate the binary algorithm, means LVP, right? And then we can find the eigenvalues and eigenvector from that LVP algorithm. So whatever output of the LVP algorithm. So here we have hybrid steps of 2 algorithms. Right? So first is LVP, second is PCA. We have hybrid the steps of that algorithm. Take the color image, convert it to grayscale, then find the mean, right? Then after the find it mean, execute the LVP, then execute the PCA, right? This is the steps with output. So first there is a color image from the FEI database. This is the images from the FEI database. We have used that images only for the research purpose, right? So this is the input image, right? So this is the color image. Second step is we need to convert that image into the grayscale image. So we have converted that color image into the grayscale. Then find the mean of each row, right? So we have find the mean of that each row. So each row has some values. grayscale values. So find the mean of your each row. Now shift image. Shift image means what? This is subtract the mean from each row. So we need to minus the third step from second steps, right? So x minus x bar. Right? So we need to find the grayscale image. Then we need to calculate the mean. After mean, we are using the shift image. We subtract the mean from each row of the grayscale image, right? So here from the third steps, we will subtract the second steps, and then we are applying the LBP, local binary pattern, right? So array and execute the LBP pattern on the step 4, this previous step, right? So we have execute the LBP, local binary pattern. Then we have used the PCA. PCA means we have find the eigenvectors, right? The best features from that output of this LBP algorithm, right? उसके ऊपर हमने we have execute the PCA on LBP. So this is the mathematical calculations of the lambda value. You can after executions you can manually calculate the lambda value also, right? For the better understanding. So this is the formula. You can calculate that. You can take the we have taken the example of 2 by 2 matrix, right? So here you can take the MATLAB. You can see the values of the image also, right? So you can take the value, that value, and manually you can calculate the eigenvectors. You can see your output will be same as your these vectors. Then you can generate the keys. Listen, if you just do the verification, that is up to you. If you want to generate the key and if you use that key for a security purpose, you can also use. So here my students have generated the key. This is the PhD research work of one of my students. So you can generate the key from that feature vector, right? You can encrypt that key with the help of that key. Means you can represent your face. From that face, you can generate the you can convert your color image into the grayscale image. Then you can find the mean of each row. Then you can use the projection, means shift image. Shift image means detect your mean, right, from the each row. Then on that data, you can apply the local binary pattern, right? You can, after the local binary pattern, you can execute the PCA on that data, right? Now PCA generates some feature vector. You can use that vector as a key also, and you can decrypt that image data with that key. Means we are generating the feature vector. That feature vector will use as a key to encrypt your base data, right? So we have used bitwise XOR operations, right? And you can now you can store that image into the database also, right? So for the security purpose, we have encrypted that images, right? So if somebody attack and somebody can fetch your data, image data, so they can not get your original data. So that's why we have encrypted the image and stored into the database, right? Okay, now the second stage is comparison, right? How to do the comparison, right? So you have to take the input from the user, capture the image, take the input from the user, right? Now do the same process on the input image, same thing, same algorithm, same steps you can execute on the database images. So you have to use for loop, and one by one you can use how to execute the same algorithm on the each database images, right? And it will compare that. First it will compare the PCA, so face, shape of the face, and then it will compare the local features of the face. So it will compare both local feature as well as the global shape, right? So compare the nearest mean, right? Inputted images, so it will compare the nearest matching of image, right? So here we have implemented, so you can see we can load the image and we can do the steps and of local binary pattern. So it will looks like this, right? And you can see this is the simple LBP. This is the simple LBP algorithm. This is the simple PC algorithm, right? Now this is our hybrid algorithm, right? So you can see that in PCA there is a false match rate, LBP again false match rate, right? Now in proposed algorithm you can see it will give the accurate result, right? Compared to LBP and PCA. So we have execute the LBP and PCA alone, then we have hybrid that algorithm, and we have try to execute that algorithm. So you can see the hybrided algorithm have the good result compared to LBP and PCA. Right, so we have just encrypted that image and stored into the database and decrypt that image for the. So this is the real-time application. We have captured. This is my image. We have captured that image, stored, and execute this algorithm. Right, you can see this is the capture the. This is the face detection. It will detect the face. Right, this is the original image. This is LBP. Right, local binary pattern. This is PC algorithm. Now let us discuss about the image readings. So subject means person. Subject means person. So if you have 5 person, each person have 14 images, and all images are in the database. Right? So you have whatever you have given the 14 images, all images are already in the database. Then the accuracy rate is 98%, PCA and LBP has 62%. But the condition is that all images must be stored in the database, right? So all images are already exist in the database. Then your accuracy rate of PCA is 90 up to 98, right? Whenever you increase your subjects, means increase your person up to 20, means 20 and 14 images. So 20 multiplied by 14 to approx to 80 images, right? So all images are in the database. Then your accuracy rate will be decreased. You can see PCA has and LBP both have decreased the ratio of recognition, right? And false match rate will be increased. Okay. Now we have comparison with our proposed algorithm. Your database have only 5 images. Only 5 images, right? So 5 subjects, then 10%, 15%, and 20%. But the images of each person have only 5 images, right? Then input images are 14 images, right? So may have your input image is not stored in the database, right? That may have 45 angle images, lighting condition images, smiling face images, etc. So input have a different images which is not exist in the database. Then you can see the recognition rate of PCA is 82% of 5% image, then 68, right? So you can see our proposed algorithm have highest recognition rate compared to LBP and PCA, right? And our database size is also decreased, right? In previous you have seen all images are in the database, but here only 5 images in the database, and you have given the 14 images with a different angle, even though we have a good result, right? Compared to this existing algorithm. Nowadays, LBP is most suitable technique. Most of all real-time applications are using PCA, right? So PCA is most widely used in market, right? Generally, they are used PCA algorithm. And you can see false match rate is decreased. So in PCA, false match rate is 70%, then LBP have 32%, while our false match rate is decreased up to 7%. Okay. So here you can see the different, this is the different readings of our algorithms, right? This is the in the form of graph, the same thing. Right? So the conclusion is that PCA is mostly commonly used algorithm, right, in a market. But if you hybrid this PCA with LBP, because PCA is work on the shape, global data, and eigenvectors, right? Where LBP is work on local data. So if you hybrid the combinations of local and global code, right, then you can do get the best result, best accuracy rate, and you can decrease the post match rate, right? So, and for the security purpose, you can decrypt the image, right? And you can store that image into the database. Right? For the future use, you can also use the clustering, right? So, in future enhance, you can use clustering. Clustering, how to use cluster? Suppose I want to search the marks of one student. How can I search? So first of all, I will search about the cluster of that student. Means that student belongs to which semester. So semester is a one cluster. Right? If that student belongs to semester 2, so I will search only in the semester 2. Right? The same way for the feature enhance, you can use the clustering. Uh, yeah, and you can use the deep learning. Right? So for example, you can, when you have input image, you can take the feature vector of that cluster, right? And local binary pattern of that cluster. For example, I have some dot on my cheek, right? Or chin. So you can find the local features, local binary values, right, of that particular area. Suppose binary value is 90, decimal value is 98. So you can search on the cluster which have a range between 1 to 100, right? Or you can search on 1 to 100. So you will search only on that cluster, right? So you will match your data, right? 98 values which is exist in which cluster. Suppose first cluster which have a range between 1 to 100. So you can, your searching timing is reduced, right? It will be reduced because instead of 1000 image, you have 100 images in the range of 1 to 100. So you will search only in the cluster 1 which have a range 1 to 100, and you have, suppose, 50 to 60 images. You can search only, and that's will reduce your time, and verification time will pass, right? So you can, in minimum time, you can get the output. So that is one enhance. You can enhance your research work by using the cluster, right? Because obviously it will reduce the time, right? If I have 1000 students, I will search one students from 1000 students, or if I have a cluster of semester 1 or semester 2, I directly move to that cluster, and I can search from 70 or 80 students. So it will reduce my time, and I can easily get my result. Right? So verification time will be reduced. So you can use the cluster also. You can use the classification also, right? Using the linear regression and multi linear regressions for the face recognition. You can use the neural network also for the feature enhancement. And so there are so many so many options are there for the feature enhancement. Okay? So this is about the this is from my side. Screen sharing. Let's start. So previously, where we are, I can repeat. Hello.
Hello, ma'am.
Uh,
Participants, if you have any doubts, you can ask, ma'am.
okay. Anyone have any doubts?
Maybe no doubts, madam.
Okay.
Your explanation
So
was very good, ma'am.
Right, you can see the output of this algorithm. Screen is visible.
Yes, ma'am.
Okay, so you can see the output of LPP algorithm. Then you can see the output of PC algorithm, and you can see the output of hybrid algorithm. Right. So PC LPP have false match rate, PCA have more false match rate and LBP and PCA hybrid algorithm, right? Hybrid algorithm have accurate result compared to LBP and PCA, right? So this is the real-time applications. We have used the real-time applications. We have applied this algorithm on the real-time applications, right? And this is the readings. You can see the readings, right? We have very good results compared to LBP and PCA, right? So the accuracy rate is up to 92%, right? When you increase, then you can see it is up to 85 to 95%, 90%, right? And the false match rate is false match, right? Your input is correct, but it will match with a false person, right? So false match rate will decrease, means it gives the accuracy rate higher, right, compared to LBP and PC, right? So this is the graphical representation, right? And in future conclusion is that it gives the better results, right, compared to other algorithms. And in future enhancement, you can use this different algorithm, classification, clustering, everything you can use. You can use also neural network also, right? And you can detect the face from the moving object also, right? You can detect the face and you can use this algorithm. Right? For the security, you can here we have used the feature vector of the same person as a key. Right? So key means the feature vector of that same person. So we have given the input, then we have color image into the grayscale image, then find the mean, then extract the mean from each row, right? Then we have done the shift image. What is the shift image? Then we have applied the local binary pattern. Then PC algorithm, we have generated the vectors. That vectors we have used as a key, right? Then using the XOR operations, we encrypt that image with that key, right? And we store that key into the database, right? So this is about from my side. If you have any query, right, you can ask.
If you have any queries, you can ask. And also attendance cum feedback form is there in the chat box. All of you please fill it. Ma'am, no doubts, ma'am. Thank you so much for your wonderful session, ma'am.
Okay. Thank you, sir. Thank you so much for inviting me as an expert.
Thank you.
Okay, sir. Thank you, sir. Thank you so much. So, yeah,
Thank you, ma'am. Yes, ma'am.
Okay. Thank you, sir.
Thank you. All participants, please fill the feedback form which is posted in the chat box. And those who have already filled can leave now. Thank you.